Over the last decade or so, we have seen a tremendous amount of advancement to mature and optimize machine learning models and AI technology, which is basically model-centric AI. You can think of these as the ways to perfect the recipe. Now, over the last few years, the focus has majorly shifted to data. And one of the pioneers to advocate and devise data-centric AI is Andrew Ng. The reason we have seen the shift from model-centric AI to data-centric AI is due to the real-world use cases and real-world data challenges. You saw with the previous example that any permutation and combination of recipes will not give us the perfect banana bread until we address the issue of ingredients. With the shift to data-centric AI, the methodology and mindset to approach the problem has also changed. Even before we think about what the model building methodology would look like, we consider three crucial things: data availability, data quality, and data validation. These three elements pretty much dictate what the modeling methodology is going to look like and how the pipeline is going to be built. We all know that AI systems powered by machine learning have become ubiquitous in our lives. But what makes machine learning tick? At its core, it's all about data. Machine learning models work by analyzing the training data to detect patterns and make predictions or classifications about new unseen data. For instance, an AI model trained on labeled images of cats and dogs can learn the visual features to distinguish between the two and classify new pet photos accordingly. The training data serves as the experience that the model learns from, like a child learning what cat and dog look like from a picture book or flashcard. The more varied, high-quality data the model trains on, the better it becomes at its given task. That is why curating comprehensive training datasets with sufficient examples is really important in machine learning. Datasets must cover all the variations and edge cases expected when the model is deployed. Models perform poorly on data that are outliers from the training distribution. Let's now dig a little deeper into the machine learning workflow and understand where the data comes in the picture. Data is an integral part throughout the machine learning workflow, from initially data collection stage to putting models into production. At each stage, quality, relevance, and availability of data matters. Let me break down each of the stages and show you how data plays a critical role. Firstly, while doing the data collection, obtaining high-quality, relevant training examples is foundational for success of a machine learning model. Data should be sufficiently covering the expected real-world use cases. Next, while we're doing data pre-processing, we need to understand that real-world data can be messy, and hence pre-processing steps like cleaning, normalization, augmentation, and balancing are crucial. Furthermore, while we're doing exploratory data analysis, analyzing and visualizing the data to understand characteristics and relationship also becomes critical. This helps us identify issues that we need to then address. Then we move on to the model training phase. This is where model learns patterns from training data examples. And more high-quality data will help us get better model performance. Finally, when we get to the model evaluation phase, we need to thoroughly test the model on holdout datasets to evaluate metrics like accuracy, fairness, robustness, and other metrics that we might be considering. This ML lifecycle is what we see in development. Production lifecycle is more complicated, but don't worry, we will be discussing that in our upcoming machine learning operations modules.